So we are now going to start with the Fleming's right hand rule. The next rule of this chapter is Fleming's right hand rule. Now let us see when we'll have to apply this rule. This rule is applicable when the following things are given. When we know the direction of magnetic field and we also know the direction of application of force or thrust. If these two things they are given, then we can think of applying Fleming's right hand rule. The next thing that we'll have to see is what we'll have to find. If we'll have to find the direction of flow of current, then 101% will have to apply the Fleming's right hand rule. The two things that we'll have to see is the given things should be magnetic field, direction of the magnetic field and direction of the force. The next thing is if we'll have to find out the direction of the flow of current or not. If yes, then 101% will have to apply Fleming's right hand rule. So Fleming's right hand rule is applied at those places where we'll have to find out the direction of flow of current. Now the Fleming's right hand rule, the convention is pretty much same as that of the left hand rule. The thing is, the forefinger will be pointed in the direction of the magnetic field. The thumb is going to point in the direction of the thrust or force. The last thing or the last finger that should be opened up is the central finger. So central finger will give us the direction of the flow of current. Alright, so let us see how to apply this thing. The thing that you'll have to remember is in Fleming's left hand rule, we have to first point the forefinger, then central finger, and then the last thing or the last finger to open up is the thumb, which will be pointed in the direction of the thrust. In this case, in right hand rule, Fleming's right hand rule, we first point the forefinger, then we'll point the thumb, and the last finger to be opened up is the central finger. That will help us in the in giving the direction of the flow of current. Let us see how. Let us take an example that magnetic field is left to right. Magnetic field is left to right. This is just an example. Magnetic field is left to right and thrust over that area is outwards, means towards your side. Out from the board, that is towards your side. So it is outwards, towards your side. Now we'll have to find out the direction of flow of current. How can we? Let us just adjust the forefinger of our right hand in the direction of the magnetic field, which is left to right. Magnetic field is left to right. So I am pointing the forefinger of the right hand in the direction left to right. The thumb is pointing in the direction outwards. The thumb is pointing in the direction outwards. Now the direction in which the central finger will be opened up, that will give us the direction of flow of current. Now the finger is opening from bottom to top, that is in the upward direction. So the flow of current will be from bottom to top. So the flow of current is from bottom to top. So it means if magnetic field is left to right and thumb is pointing outwards, then the direction of flow of current is bottom to top. Let us just reverse this case. If magnetic field, the direction of magnetic field is same, left to right. Instead of outwards, now the force is acting inwards, that is away from you or towards the board. Now let us see how the direction of flow of current will change. So the forefinger of the right hand left to right and the thumb is pointing inwards, inside this board or away from you. Now the finger or the central finger of the right hand is pointing downwards, which means the flow of current is from top to bottom. So the flow of current is from top to bottom. Alright. So this is how, by changing the direction of the application of the force, we have changed the direction of the flow of current. Here is bottom to top and here is top to bottom. We can also change these alterations by changing the direction of the magnetic field. So this is about the Fleming's right hand rule, where to apply, where these two things are given, and we'll have to find out the direction of flow of current. And how can we apply that we have seen. Now there is the next part that we'll have to discuss, the various concepts that we should know before understanding the working part of the AC generator. The Fleming's right hand rule will also help us in determining the direction of the flow of current, but there are some additional concepts that we should know. So now we'll discuss the additional concepts that we should know before the working part of the AC generator. Let us start with the understanding of the various concepts that we should know before the working part of the AC generator. So, concept of angle. This concept of angle we have already discussed for the DC motor also. So, we'll have to keep that in mind. Only then we'll be able to understand the concept of angle for the AC generator. If you remember, we have discussed the angle theta in that case, where theta is the angle between the plane of coil or plane of armature and magnetic field line. And where theta is 0 degrees, we say that 0 degree is the starting position of the motor. So this is the starting position of the motor, and theta is the angle between the plane of armature and magnetic field line. And if you would remember, the armature initially was placed at this 0 degree, and then when it starts making turn 90 degree, then it make turn 180 degree, and so on. It will move in one direction. It will continue to rotate in one direction. So the starting position of the coil or armature was this, where the plane of armature, that is this, and the magnetic field line, they form an angle 0 degrees, the starting position. Now for generator, for AC generator, there is a different starting position. The starting position is this. This is the starting position of the AC generator, and not this, which is the starting position of the motor. In starting position, this was the, you would say, the starting position of the motor, where the angle is 0 degree, and in this case, the angle is 90 degrees. In order to avoid this confusion of 0 degrees and 90 degrees, we'll be still saying it as theta equals to 0 degree, but the thing is, we'll change the angle between not the plane of armature but the axis of the armature and the magnetic field line. Let me see how I can change the angle theta for generator. This is for the motor when I am saying, and now I am saying theta for generator. This is the angle between the axis of armature and magnetic field line. So this is for the generator. When we have to consider a generator, we'll see theta between these two things, not the plane of armature but the axis of armature and magnetic field line, in order to make this theta still as 0 degrees. How? So theta is 0 degree. Again, the starting position of generator. The starting position of generator. Now, just understand, if this is the plane of armature, the axis is always perpendicular to this plane of armature. The axis, this is the axis which is passing through the plane of armature, which is perpendicular to the plane of armature. Now, we know if magnetic field lines, in the case of generator, this is north, this is south, the magnetic field line is flowing left to right like this. And the armature is now placed like this. the armature is now placed like this, such that the plane of armature is perpendicular to the magnetic field line, which means theta is 90 degree. But in order to avoid this confusion, we'll still want to make this angle 0 degree. So the theta, we have changed the notion, or we have changed the angle from plane of armature to axis of armature. Now the starting position is this. This is the axis of that armature. Now this axis and this magnetic field line is making an angle 0 degree. This axis of armature now and this magnetic field line is now making the angle 0 degree. So the starting position of this generator is now this, where the theta is the angle between the axis of the armature and the magnetic field line, which is again 0 degree. So just by changing the definition of theta, we have just acquired that theta will take in both the cases, generator as well as motor, in as 0 degree. So this is the starting position where the armature is placed 90 degree. The plane of armature is perpendicular to the magnetic field line, but the axis of the armature is parallel to the direction of the magnetic field line, giving theta as 0 degree. So the important thing that we'll have to remember, in motors the armature is placed like this, and in generator the armature is placed like this. Starting position of motor is like this, starting position of generator is like this. Alright, so this is one of the important concepts that we should know before starting with the working part of the AC generator, that starting position of starting position of generator is like this. Plane is perpendicular to magnetic field line, but the axis of armature is in the direction of magnetic field line, giving this theta as 0 degrees. So after this, we'll now start with the working part of this AC generator.